When we look at the graphs of polynomial functions, we're going to describe these things in a couple different ways in terms of the behavior that's happening here. One of the first ways we're going to describe is whether the function is increasing or decreasing. And really, when we look at increasing or decreasing, we always go left to right, and we're going to express this in interval notation, which is why we just looked at interval notation. But if the function is increasing, if y is increasing as x increases, all right, basically it's saying, hey, as we go from left to right, if the function's going up, it's increasing, all right? A function is decreasing if y decreases as x increases. Again, x increasing just means we're going left to right. So if the function's going down as we go left to right, the function is decreasing, all right? So when we look at increasing, decreasing, we look at the function for left to right and decide, okay, is the function going up or is the function going down? And then we're going to express where it's going up and where it's going down in interval notation, all right? So basically that's going to be described in terms of the x. We have turning points. A turning point is basically any place that the function changes direction, all right? So when it goes from increasing to decreasing, or when it goes from decreasing to increasing. We also have special turning points where the function changes inflection, which we'll talk about a little bit later. But turning points are basically any time that the function changes direction, when that curve shifts the direction it's already been moving in, okay? Relative max and mins, these are specific turning points. Okay, a relative maximum is any place where the function goes from increasing to decreasing. And it's called a relative maximum because it's a maximum based on the points around it, okay? So it's bigger than the points on either side of it. A relative minimum was where the function goes from decreasing to increasing. And again, it's a relative minimum because it's a minimum relative to the points around it. Okay? It's like if we looked around this class and found the tallest person, they would be a relative maximum because they're the tallest person in this class. They're the tallest compared to everyone around them, but they're not the tallest person in the world. So it's not necessarily the highest point on the function, but it's higher than the points on either side of it. Okay? Relative minimum would be the same analogy if we looked at the shortest person. Of course, we don't want to embarrass that person, so we'll let that go. But again, relative maximum, it's higher than the points around it, so it's a high point. Relative minimum is a low point. And these are special turning points. Maximums where the function goes from increasing to decreasing. Minimum where it goes from decreasing to increasing. Okay? So if we look at an example here, here's an example of a graph of a polynomial function. And I'm basically just going to identify each of these different things. So I'm going to identify where it's increasing, where it's decreasing, any relative maximums or minimums. And then the last thing I'm going to do is talk about the end behavior because we all love end behavior so much. Okay? So when I look at this thing, if I look at this graph, increasing, again, I just go from left to right. So as I look at this function from left to right, as I travel along this function, I can see that at first I'm going up as I travel along this function. So right here I'm increasing, and then all of a sudden the function starts going down, so now I'm decreasing. And then the function starts going up again, so I'm increasing once again, all right? So as I go from left to right, I can see the function going up and then down and then back up again. All right, so the function is increasing everywhere I see green. And so when I label that, again, I'm going to label in terms of x. The function is increasing from whatever this point is out here until I get to this point right here. All right, and when you think about where it's increasing, when you think about these x values, let's think about this in terms of x. If I were to draw like a number line here, it's basically like the timeline of the function, and we're describing, all right, what is it doing on this timeline? So we start back here at negative infinity for x, and this thing is increasing, it's increasing, it's increasing until I get to right here at the value of negative 3. So in other words, the way I express this in interval notation is I say that the function is increasing from negative infinity to negative 3. Okay, so that goes in my increasing section, and then I just have to decide, am I going to use brackets or parentheses? So when I think about negative infinity, should I use a bracket or parenthesis? Well, with infinity, I should always use a parenthesis because I can never equal that value. And then when I think about what's happening right here at negative 3, at this point itself, is the function going up or down? And the answer is it's not doing anything. It's not going up or down. That's a relative maximum. So it's not doing either of those things. It's not increasing. It's not decreasing. So when I draw this in terms of increasing, when I write the interval notation, I'm going to use a parenthesis here. I'm going to say, hey, that point is not included because I'm not increasing or decreasing at that point. Okay? The other spot that I'm increasing, if I keep going with increasing, again, if I think of this in terms of the number line, down here from this point right here, from here on up, it's increasing. So over here I have positive infinity, over here I have positive 3. So from positive 3 to positive infinity, it's increasing in. So I label it in terms of x, all right? And that's the tricky thing about increasing and decreasing. We identify it in terms of y, but we label it in terms of x. So again, from 3 to infinity, on that spot, from those values, the function is going up. And again, 3 is not included because that point right there, that's a relative minimum. It goes from decreasing to increasing. At that point, it's not decreasing or increasing, so I don't include the 3. I never include the infinity. And now because I have two sections that are included in this increasing portion, I put a union symbol in between. Okay? So I slap this union symbol in between to say, hey, these two intervals are included on the same thing. They're both part of the increasing portion of this function. All right? And then when we look, the section is red. We can see it right here. It's from negative 3 until positive 3. So again, parentheses on each because it's not increasing or decreasing, but that's interval notation. All right? Interval notation is showing us that we're going from increasing to decreasing. All right? Interval notation is what we use for increasing and decreasing when we're labeling from one x value to the other. And you can see the interesting thing here is that every x value is included. See, from negative infinity to negative 3, the function was going up, and then from negative 3 to positive 3, it was going down, and then from positive 3 to infinity, it's going back up again. So every x value is kind of listed here at some point, all right, in some way. Okay? And then we jump to relative maximum. And we look at relative maximum. A relative maximum is just a high point. It's where the function goes from increasing to decreasing. And I kind of already labeled this. I labeled it right here in purple. All right. And if I label this ordered pair, that's negative 2, positive 4. And so when I look at something like this, negative 2, positive 4, that's my relative maximum. So that's what I write down for relative maximum, negative 2, positive 4. And then relative minimum, again, I already kind of labeled this. Here the function goes from decreasing to increasing. That's the ordered pair 3, negative 2. That's my relative minimum. It's just a low point on this thing. And keep in mind, you could have more than one relative maximum. You could have more than one relative minimum. And the interesting thing here is when you look at increasing, decreasing versus the relative maximum minimum, you have to understand that increasing and decreasing is interval notation, and relative max and min, those are ordered pairs. And how do I tell the difference between interval notation and ordered pairs? It's really the context. If I'm talking about increasing, decreasing, I'm talking about an interval. And if I'm talking about relative max or min, I'm talking about ordered pairs. It's like if I use the word fly. All right? Am I talking about a fly on the wall, or am I talking about flying through the air? The difference is the context. If I use it in a sentence, it's going to be pretty obvious whether I'm talking about a bug or whether I'm talking about an airplane. Okay? And so, think about that in terms of the context. If it's increasing, decreasing, it's interval notation. If it's relative max and min, then we're talking about ordered pairs. And so the last thing we're going to look at, and we've looked at this before, is end behavior. And the end behavior, again, these are all parts of the graph that we're describing. The end behavior, remember, is always we're looking at x going to negative infinity, and then we're looking as x goes to positive infinity. And so negative infinity is like the left-hand side of the graph. And so when I look at the left-hand side of the graph, I can see that the function is going down forever. So I say that f of x, my y values, are going down forever. So they're going to negative infinity. All right. So as the function goes to the left, it goes down forever. As the function goes to the right, that's positive infinity. Here's positive infinity off to the right. I'm going to say f of x goes to positive infinity. All right, so the function goes to the right, it goes up forever. All right, so we're just describing each of the pieces of this graph. And what we're going to start to do is find increasing, decreasing on our own. We're going to find relative maximums and minimums on our own so that we can do a complete graph of these polynomial functions. Okay?